Exercise astrophysics question 10. Explain why the moon is visible from Earth. So what is the reason why the moon is visible from Earth? Because moon is not a luminous object. It is reflecting the light of sun. One mark is for reflecting the light, another one is for the sun. Then you can see here they mentioned the cycle of the moon. As we know, 28 days are there, 28 approximately. So first what we have, we'll have new moon is there. Then 14 days we'll have a full moon. So in 7 days, because we want to sketch the position. So in 7 days, what we'll have, we will have the first quarter, it will be there. Yeah, so when we draw this, the first quarter, because like the position will change, like 0 days, 7, 14, and then 21 days is there. And then again, 28 days, again, we will have a new moon, 28 or 29 days. So which part will be visible as I mentioned here? So the shaded side, like here, this part is visible after 28. So 7 days, which part should be visible? The other part position should be visible. So means it should be like this. That this part, first quarter is there. And then again, after 28, like there will be representation is there. You can say a full new, because there will be first no moon and then there will be a new moon will be there. The new moon actually it's like not able to reflect the light. So how we represent a new moon? So same as the first one. Is it clear? The phases of the moon, how we sketch?
Yes, sir.
Okay. And state what the state what phase of the moon indicate about the motion of the moon. So what it indicate about the motion of the moon is it simply indicate that moon is orbiting the earth and with a time, because like here we have a new moon and after 28 or 29 days new moon, so we can say with a cycle of 28 days on average approximately we can say 28. So moon is orbiting the earth with a orbital time of 28 days. And the time, orbital time is equals to 28 days. The average radius of the moon is 3.84 exponent 5 kilometer. The average orbital speed is 1025. Calculate the time period of a moon to complete one orbit. Now for this, if the distance is given in kilometer, so speed should be in kilometer per second, or if a speed is in meter per second, distance should be in meter as well. So we have to convert the units. Say this is representing our Earth. And this one is a moon. So this distance is given 3.84 into 10 power 5 kilometer. But the speed is in meter per second, so we have to convert kilometer into meter, and that is actually the radius of its orbit. So to convert kilometer into meter, we multiply by 1000. So when we multiply by 1000, this will be 3.84 into 10 power 8 meter. This is in meters. Now orbital. So we have the formula. Whenever object move in a circular path, the orbital speed is 2 pi r divided by t. If we need time, orbital time, so time is equals to 2 pi r divided by speed. So it will be 2 into 3.14 into the radius, which is 3.84 into 10 power 8, and divided by speed at which it is moving 1025. So when we divide, it will be 2.35 exponent 6. Okay. So that's equal to 2.35 into 10 to the power 6, and the unit will be seconds. Is it clear, this one? How we work out the orbital period of the
Yes,
moon?
sir.
Okay.
Yes, sir.
Okay. Then we have the last question from this exercise, which is about the redshift. So light from glowing hydrogen in distant galaxies is redshifted. What is meant by redshift? So what is the meaning of a redshift? It means that the wavelength which we receive, like it's not like wavelength is emitted out from the wavelength which we observe or we receive is having a longer wavelength. So we can mention here what is the meaning of a redshift. When wavelength increase due to the object moving away, yeah, or the increase of the wavelength which we observe, or wavelength of a light which we observe from emitted out from different galaxies appear to have longer wavelength than emitted one. Like it is emitting out different wavelength. Say a galaxy is there which is having hydrogen or helium, any other element is there, and that element is example. This is just an example. Say that element is emitting out a wavelength of 2 meters. But when we receive on Earth, we don't receive its 2 meter. It appears like it is 2.5 meter. It's not like what is emitted is longer. It's what we observe is longer as compared to what is emitted out. So we call that as a redshift. So the wavelength observed appear to be longer than the wavelength emitted from the due to its motion. Because the object is moving away from us, so what we receive a different what is actually emitted out. State what can be deduced from a redshift from a galaxy. So redshift indicate that this galaxy is moving, the distant galaxy is moving away, and its speed, yeah, the galaxy is moving away from us, and higher speed means like it is moving, it will give a greater redshift. So galaxy is moving away from us. One mark is for mentioning moving away, and we can identify its. Then so this one is showing what we can deduce. It deduce that the galaxy is moving away. And also given evidence that universe is expanding. One method for estimating the distance of a distant galaxy. So how we can identify, actually this is sending a light and measuring a, okay, no, actually what happened, we are observing the star, like we focus because like uh, every galaxy is like it's a supernova, like there are massive stars in which undergo a supernova. So how we actually estimate the distance of the galaxy, that is observing the supernova, like observing the brightness of a supernova. We identify, like example, if it appears much brighter to us, we can identify that it is closer to us. If it is dim, because well, due to supernova, it give out light, and that light is as an indicator is used to know which galaxy is closer and which galaxy is further. So we can use the brightness of a supernova to estimate the distance of the galaxies. And how, according to the Big Bang theory, the 1 over Hubble's constant represent the age of the universe. So you will simply, it's a short derivation is there. Look, according to Hubble's law, the speed of a galaxy is equals to Hubble constant time the distance. Then speed divided by distance is Hubble's constant. Then we know the formula speed is distance over time. So time is distance divided by speed. Means it's, so reciprocal of this v over d is 1 over t. So we can say 1 over t is equals to h naught. Or we can say t is equals to 1 over h naught. This is a simple definition. We just have to explain how, according to a Big Bang, like the reciprocal of the universe, reciprocal of the Hubble constant is age of the universe. So according to Big Bang, like explanation, this is the derivation, but how you explain this, you'll mention according to Big Bang, everything was a point of like 1 point. And then what happened? It exploded. As a result of explosion, those galaxies move away from each other, everything move away from each other, and with a speed v and distance is d. And the reciprocal of the time is equals to the Hubble constant, or Hubble constant reciprocal is equals to age of the universe. So according to Big Bang theory, all galaxies or matter which is originated is always from 1 point in the space. And if the distant galaxies travel from when it was in contact with the Milky Way, the distance is d and the speed is v. So using the distance d and speed v, we can find the Hubble constant and reciprocal of the Hubble constant. We will know that what is the age of universe. Is it clear, this one? So
Yes, sir.
it was all 1 point. And then galaxies or everything move away from each other with the speed v and the distance d. And using v and d, we find Hubble constant. How the marks are divided? First mark is for mentioning it was all 1 point. Yeah, I'm explaining the question. See how, according to a Big Bang theory, 1 over h naught represent the age of universe. That's the question. So everything was 1 point. Like example, Earth and say galaxy A, or Earth and galaxy B, all the things were 1 point. So how much time this galaxy, when we are observing this galaxy, how much time this galaxy took to move away from Earth, that time is actually the age of universe. Same thing, how much time this galaxy B took to move away from the Earth, that is the age of the universe. And all these galaxies are like the, when we work out the time using a Hubble's law, we are getting the same answer, because those galaxies which are closer, they cover a shorter distance, they're moving slower. But those galaxies which are far, they're accelerating and their speed is increasing and they're covering longer distance. So according to Big Bang theory, how 1 over h naught represent the age of universe? First thing, it was all 1 point. Then the distance, when it is scattered, the distance is d, distance of galaxy is d, and the speed is v. And then using the v over d, we guess the Hubble's constant, and from Hubble's constant, reciprocal of the Hubble constant, we get the age of universe. So first, we focus on this galaxy and we find what is the distance of this galaxy and what speed it is moving. After knowing its distance and speed, we find the Hubble constant and we take a reciprocal of Hubble constant. We get the time, and that time is actually the age of universe. Is it clear?
Yes, sir.